Okay, so where did we leave off here? It was with example 1.4, commutativity of complex multiplication. So they're multiplying two complex numbers. See, notice it says alpha and beta are elements of the complex numbers. So alpha beta equals beta alpha. That's commutativity. So he wrote a plus bi and for alpha and c plus di for beta. A, B, C, and D are real numbers. We did the multiplication before. He says the equations above and the commutativity of multiplication and addition of real numbers show alpha beta equals beta alpha. You know, why don't we show that here? So alpha beta, well, alpha beta, he got AC minus BD plus AD plus BC I. And for beta alpha, he got CA minus DB plus CB plus DAI. Now let me see if I can get this to focus. Okay, that's a little better. Now if these two are going to be equal, this AC minus BD will have to equal CA minus DB. What will make that work is if AC and CA are equal and BD and DB are equal. But what were A, B, C, and D? Those were real numbers. So you already know from the properties of real numbers that AC does equal CA and BD equals DB. So in fact, what this is from the left to the right is commutativity of real numbers. And the same thing will work here. AD interesting. So notice the AD plus BC under addition is commutative. So here, let's do it like this. AD plus BC by commutativity of addition of real numbers is BC plus AD. And again, by commutativity, BC is CB and AD is DA. And so that shows the top is equal to the bottom, AD plus BC on the left, CB plus DA on the right, or on the bottom there. I said I would try and do a problem, so let's go to the problem set. All right, with the magic of video editing, let's do problem number 1 and show that alpha plus beta equals beta plus alpha for all alpha and beta a complex number. Oh, you can't see that, can you? Sorry about that. Alpha plus beta equals beta plus alpha is what we want to show. Well, alpha is of the form a plus bi. That's all we know. That's the definition of a complex number where a and b are real. And beta is c plus di, where c and d are real. So by definition of addition for complex numbers, this is just the same thing as a plus bi plus c plus di. But what does this mean? Well, to add two complex numbers, by definition, you add the real part and the complex part. And the real numbers, by definition, are commutative. But by definition, this is just c plus di plus a plus bi, again on how you add complex numbers. But c plus di, that was beta. And a plus bi, that was alpha. So we've shown what we wanted to prove. I don't know, QED, whatever. The, what is it, the Hamma symbol? Whatever. However you want to end. So that shows that alpha plus beta equals beta plus alpha. And that's all I'm going to do. I already did like 2 problems. I just wanted to get a little bit into this book, and maybe we'll do more later if we're interested. Thank you.